Alright, I got the front differential here apart on the Polaris 500. This is the on-demand drive differential. And I just wanted to make this video because I was having a terrible time finding good information about how this thing actually works. Now, if you're like me, I can open it up and I can probably replace bearings and fix it all, but I want to understand exactly what makes this thing work. Like, how is it actually functioning in real time? So that's what I'm going to try to show you here right now. So when I opened this up, I was like, what in the world's going on here? Because it didn't make sense right away. Maybe to you, when you look inside, it'll make sense right away, but it didn't to me. So what I'm saying is I'm trying to make this video to help you understand how this thing works. Okay, so in the middle of the differential, you have this main driven bearing, which is driven by this input, gear. That's what I meant to say. Gear is driven gear that's driven by this input gear right here. Okay, so this thing is always rotating when the back wheels are in motion. You hear what I said? This piece rotates with the input from the drive shaft. The same power that's connected to the back wheels is always connected to this front piece. So this piece, anytime the back wheels are spinning, this piece is spinning right here. There's power coming to this differential. Now, in the sides of the differential are two of these pieces that slide inside. See that? They slide inside. And these two pieces are splined, as you can see, and the side drive shafts for the front wheels connect into these. Now, these can spin independently of the back wheels because there's nothing connected. Now, I'll show you this. Inside this front differential, inside this main ring gear, the driven gear, is this cool little invention that I don't know if Polaris came up with this or who invented this, but this is pretty neat. You gotta take a look at this. What this is a little cage that has a whole bunch of rollers, and it's kind of junky looking right now, but I'm gonna clean it all up and make sure it's nice and not corroded or anything before I put it back in. But the purpose of this is just to show you how it works. So these rollers are sort of loose, and you can see they can just pop right out. They're not like bearings. They don't function like bearings. I'm gonna show you how they work. So you want to be careful when you take this apart that you don't let them all drop out, because they could if you bump this thing the wrong way. So all these rollers around here, there's 1, 2, 3, 4, 5, 6, 7, and there's 2 side by side. So there's 14 rollers all the way around. And those 14 rollers fit perfectly inside this thing in these 7 grooves. Can you see those 7 grooves? Alright, so what's going on here, under normal use, whoop, there I lost one of my rollers. Let me get this back in here. These rollers fit right in those grooves, and they aren't pushed against anything, they're not contacting anything, they're just rolling there freely. Okay, so remember, bear in mind, this whole piece is rolling with the power from the transmission, the same power that's going to the back wheels. Anytime the back wheels are turning, this piece is turning. Even if the front wheels are standing perfectly still, this piece is still rolling. Okay, if the back wheels are spinning. Now, what happens when you engage your four-wheel drive is what I'm about to explain here. See, these Polaris machines, these ATVs, they have an on-demand drive system. That means that when you click that four-wheel drive button on, it's not necessarily in four-wheel drive. You could call it all-wheel drive. I'm not sure if it's technically all-wheel drive or not, but anyway, the point is that there's not necessarily any power going to the front wheels at that point. The idea is that it's supposed to give power to the front wheels when it feels like it needs power. Now, that is not accomplished by sensors that sense when the back wheels are spinning and engage an electric clutch in the front differential. That's not how this works. I've heard people say, or I was reading people that said that the machine senses when it needs power to the front wheels and then it applies power. That's not really an accurate way of saying how this thing works. I'm trying to show you that this is a completely mechanical system. It's not engaged as far as the on-demand part is not engaged electronically. So this little piece right here is the piece that does all the magic to make this thing work. What this is, I forget now what the technical term is for it. It's an actuator plate is what I would call it. And see how it has all those little tabs? Excuse me. See all those little tabs on there? Well, all these tabs fit into grooves on that cage that's in the middle of this driven ring gear. Okay? So this whole mechanism is spinning at the speed of the back wheels. You got to keep that in mind. When you're driving down the road, this whole piece in the front differential is spinning at the speed of the back wheels. Okay? Now this piece is connected to your front wheels. It's locked in. This piece cannot spin without your front wheels moving. And there's two of these pieces, one on each side, but I'm just showing you on one side to keep it simple. Alright? So this piece is slid right in there, and it can spin independently. Right? Either way. Doesn't matter if your back wheels are spinning or not. This piece is going to spin freely. And therefore your front wheels are going to spin freely. If you get stuck in the mud, your back wheels are spinning, this whole piece is going to spin with the back wheels, but your front wheels are not. They're not going to spin because this is not engaged. But, now here's where it all comes together. See this piece right here? This is the side plate of the differential case. And there's an electric wire going in here. What this does, when you click on your on-demand drive, four-wheel drive, you click that on, this is going to give power to a magnet that's right in here, and it's going to cause it to be magnetized. This actuator piece actually sits right against that. And this is all put together. I'll just demonstrate for you real quick. Alright, so this actuator piece is right in here, spinning like this. Alright, spinning, spinning. When you click that on, it causes it to get magnetized to this piece, and it causes it to slow down. Now this is the key. This is a key part of it, so make sure you pay attention to this. So, let me give you your scenario. So, you're just rolling along. Nothing's locked in, everything's spinning freely. This piece is spinning with the power from the back wheels, or the power from the transmission, but it's important to realize that it's the same power that's going to the back wheels. So, this is just spinning away like this. And as soon as you hit that switch to put it on four-wheel drive, what happens, this piece gets magnetized to that case like I showed you, and it acts like a brake. It slows down. And what that causes it to do, as this is rotating, this piece, it locks back. Now I'm going to try to see if I can push it, for the sake of illustration, push it back to where it's locked. Okay? So there, I just locked it in. That's all it took, a little fraction of a turn. So now, what just happened? Remember all those rollers that are in those grooves? What happened when this piece locked back, it rotated that inner cage just very slightly, just enough for all those rollers to push up against the sides of the grooves. And what that does is it forces all those rollers to clamp down on this middle drive shaft piece that's going here. And now, because that whole thing is clamped down, this whole piece is now locked together. And now, you're going to see here, if remember how before I could spin this freely, this front wheel? Now, as it's spinning this way with the power from the engine, because the back wheels are still spinning, now it's forcing this side drive shaft, if I can keep it locked in here, it's forcing this side drive shaft to move with it, thereby giving power to the front wheels. Now, I said before that this system is not a mechanically engaged on-demand drive. And what I mean by that is that the system does not have a computer that tells the front wheels when they need power. It doesn't sense when the back wheels are spinning and apply power to the front wheels. No, what it does, since this is spinning with the back wheels, it acts like a ratchet. Since this inner cage is engaged, it forces these wheels have to spin forward. The front wheels have to spin forward with this power that's coming in because the back wheels are spinning. Now, when you get out of your mud hole or whatever you were trying to get through, this piece picks up back up speed to the same speed as the front wheels are moving because they're not spinning anymore. It slows down to the same speed as the front wheels. And now this thing is allowed, your front wheels can always spin in this direction, but since the demand drive is still engaged, it cannot spin backwards. So it has to keep pushing. Anytime the back wheels start spinning, it's going to push against those little rollers in there, and it's going to cause it to lock down and spin this front axle. But when your back wheels stop spinning, they're going to be turning at the same rate as the front wheels, and this thing it's free to move the other way. Okay? Now what happens, as soon as you click that switch off, so it's just in two-wheel drive, this whole piece, this actuator piece loosens up and it can now move back and forth. So that middle cage with all those rollers is not engaged anymore, and the front wheels can now spin freely. So there's no power going to the front wheels anymore. But if you click that back on to where this piece is locked in, like it's like a brake on this actuator piece, it causes that middle cage to lock in, then lock it in there. It's hard to do by hand. Then, as soon as it needs power, it's going to act like a ratchet, and it's going to push power to this drive shaft going to the front wheel. I hope that makes sense, and I tried to explain it the best way I could. If it didn't make sense, let me know, and I'll try to do it again, or try to explain it better somehow. But that is the Polaris on-demand drive system, and it's actually a pretty brilliant system because it's all automatic, but it's mechanical. Yes, it is switched on electronically, but it is not actuated electronically. As far as whether the front wheels are actually getting power or not is not controlled electronically. It's all mechanical. It's determined by whether, it's like a ratchet system, it's determined by whether those little rollers are forced against the grooves in there. So I hope that makes sense. If not, let me know.